is actually a unitless unit.
Hmm.
It shows up when it's convenient, and you take it away when it's convenient. What happened to the radians? You can stick the radians in there or leave them out. So why on earth do we have a unit that doesn't need to be set? For clarity. If I said that I had something moving through an angle of 30, you do not know whether I'm at 30 radians or I forgot to save degrees. So you would, if I'm at 30 radians, it's helpful to say radians because then you know that I didn't forget to save degrees. We're talking about radians. This is going around the circle several times. So you put radians in when it makes communication clearer. And you take it out when you don't need it. A number of years ago, I had a student, a 151, 152 student, who, just for fun, stuck radians at the end of all of his answers. It's not technically wrong. Questions do you hear? All right. Now to the races. I have two objects here. They roughly have the same radius. This has much more mass than this does. The question is, if I release these at the same time, which is going to get to the box first? So what we're going to do is we're going to do some non-monetary gambling. So we have the solid, I assume it's a solid, I think that's a solid sphere. We have the solid sphere, which I'll represent by this solid, and then we have the hoop. And I'm going to leave neither off. All right, so if they were released at the same time, which we'll get to the bottom first, I want you to have an opinion. If you're not taking notes right now, you need to put your computers down or close them. You're taking notes on your computer? So have an opinion. Who thinks this is going to get down first? Okay, let's try that again. Who thinks this is going to get down first? 1, 2, 3, 4, 5. Isabella, you changed your mind?
Oh, yeah, I guess so.
Who says this is going to get down first? And who says it's going to be a tie? 1, 2, 3, 4, 5, 6.
It's a tie.
Pardon?
Said it's a tie for a tie.
All right, to release this. That's slightly tilted there. Well, it is where it is. That, all right, here we go. Clearly won on that one. Usually I switch them around just to see if there's any imbalance in the two tracks here. So the ball clearly won that time also. So why does the sphere get down first?
Is it heavier? It's heavier, solid.
Why would that make a difference? So, if it's a matter of heaviness, pretty sure that's solid also. So you're saying this one would win?
Do they weigh the same?
Not according to me.
Nothing. I don't know if this was matching. That's way lighter.
Okay, so the blue one's heavier. So according to what you're saying, this should win.
Mm-hmm.
All right, let's see who's with you. So we will again. I've got the big one, and the small one, and then. Who says the big one's gonna win? 1, 2, 3, 4, 5. Who says the small one's gonna win? 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7. Oh, 7. Who says it's gonna be a tie? No one. It's a tie.
We're all wrong.
So why is it that the circle, the sphere clearly beat this, but that's a tie? Apparently it's not having anything to do with the actual weight of it or the mass. Speculation. Let's see, that's the. All right. They have roughly the same diameter. Pretty sure this mass is bigger. Verifying which one's bigger. Which one has bigger mass? This one? Okay. So this one has more mass. So the solid disc or the hoop? Who thinks it's the solid disc? Solid disc gonna win the 1, 2, 3, 4, 5, 6, 7, 8, 9. Who says the hoop? No one. Who says the tie? 1, 2, 3. Let's find out. The solid one won. All right, we're slowly getting there. Why?
There could be some resistance on the, since there's like the open gap. I'm not sure why the other ball would tie, but since there's it's an open circle, there could be some resistance to there instead of being solid.
Oh, air resistance?
Yeah.
Based on my knowledge of air resistance, I think that's gonna be minimal. I think if this were a really long race, that would have an effect, but I don't think they're going fast enough for air resistance to play not that major a factor. Well, so far, these are the ones that won, so I guess the question is, which one of these will win? Who's willing to gamble their grade on it? All right, so we've got the solid one, we have the sphere, and then tie. So, disc and solid sphere. Mass doesn't seem to have much to do with it, but please tell me which one feels like it weighs more. That one? Okay. So this one weighs more. therefore has more mass. The radiuses are about the same. So who says black disk? Who says the sphere? 1, 2, 3, 4. I think there was 5, 6. And who says a tie? 1, 2, 3, 4, 5, 6. Slightly there. Didn't seem as tie-like as the other ones were, but let's switch sides there. It looked like the sphere had a slight lead, not much of one, but a slight lead. And that is what I would expect. So congratulations to those 6 people. Yeah, this does have something to do with the stuff we were just talking about. Why does one thing roll faster than another? All right, when we did the 2 balls, that was looked like a tie. So the size of it does not seem to have any significance. The mass of it does not seem to have any significance. If I took these two, and hopefully they're not going to be going fast enough for air resistance to matter. I have a hollow ball and I've got a solid ball. Which one now wins?
Solid.
All right, so solid and hollow. I don't believe in you. And tie. So it looks like solid is the favorite. Why? Why is solid a favorite?
Because it seemed to be doing good in the
Oh,
past.
okay. It's track record. Okay. And it sure seemed like it won that time. You know what I'm going to do is I'm going to write some formulas over here. Coming from the book, or that was it page 138, is that what I said?
Yeah.
Okay, so page 138. So a hoop rotating about its center. So hoop. Moment of inertia is m/r squared. For the solid disk, I is 1/2 m/r squared. For the solid sphere,
2/5.
what'd you say?
Is it 2/5?
Yep.
Is that
I is 2/5 m/r squared. And for the hollow sphere, or thin-shelled sphere, did they word it, they have the thin-shelled or hollow sphere on the list?
hoop about?
Okay.
You mean a solid cylinder?
No,
No.
no. The hollow sphere, I is 2/3 m/r squared. And
Yeah, they don't have this one in the book.
I think,
Or that one.
I think those are the only shapes we rolled. Oh, I guess not. Thin hoop. Thin in terms of that. And Yep, we'll leave it at that. All right, so between the solid ball and the hollow ball, solid 1. Sort of look over the equations and see what the differences are. Between the disc and the solid disc and the solid ball 1, a little bit, by a little bit. Well, solid ball should win that race. What about disc and hollow ball? We haven't done that combination. Disc and hollow ball.
I think the disc.
So there's a couple people voting for that. Anyone in favor of the hollow ball? They still don't believe in you. Okay, think about what the differences are in the formula. Hollow ball and hoop. So, Anna, you're going for that one. Got a couple other people pointing over here. Anyone like the hoop? All right, you got a fan. You're also a hoop. So we got 2 for the hoop and the ball. And got another vote. Ooh, looks like we're somewhat evenly split. You're going for the ball? Your favor of the ball? What about a tie? Now, Anna, you were very quick to pick your favorite. Do you have a reason for it, or just gut feeling at this point?
I feel like the shape of the ball, because there's not as much force like keeping it. Like, do you know, like the shape of that? It has like it can't go any direction.
Ah, okay. It does have something to do with the shape, but the reasoning's not quite there. Ball by a little bit. What's the difference between these formulas?
The number in front of n.
Okay, so when I did solid sphere versus disc, solid sphere won. Any thinking about why? What would determine that?
One's a higher number, one's a smaller number.
Okay, which one wins?
It was a disc and a solid sphere.
Sorry, louder?
The smaller number.
So if I did hollow sphere versus solid sphere, that's a smaller number than that is. And solid sphere won.
Mm-hmm.
When I did thin hoop versus hollow sphere, I have, it's an implied 1 right there.
That's what
1
I was
versus
wondering.
2/3.
Yeah, I was wondering. I was like, is that an implied 1 or is
Yeah,
zero?
there's
It's
an
one.
implied 1 there.
Okay.
And it turns out it is. It's the smaller number is gonna win.
Okay.
Why? All of these formulas, remember, if we go back to what I had down here on a previous screen, if we don't want to go too far, there we go. The moment of inertia is just the sum of all these mr squared. It is the sum of, as this thing is rolling, how is the mass distributed? And not only how is the mass distributed, where is this? And not only is the mass important, but how far away it is also makes a big difference here. It's r squared. R is going to have bigger impact than m is because there's just one m. So that, there it is. So the big thing right there is that number up front. And again, there's an implied 1 there. These have the same number up front, they're both solid balls, they're both the 2/5 mr squared. And by the way, it's a capital M and a capital R. It's just usually tradition that if you're talking about moment of inertia, capital M means the mass of the entire thing, capital R means the radius of the entire thing. As opposed to little m, little r, which is all the individual pieces. Since these tied, they were going the same speed when they get to the bottom, same linear speed. This is bigger mass, they had the same speed, which had more kinetic energy at the bottom,
The big one.
okay? Which one had more potential energy at the beginning?
The small one.
Why?
Because
What type of potential energy are we talking about here? What conservative force is causing this thing to go down the ramp?
Force of gravity?
Yeah. And the force of gravity is not changing significantly over this small distance here. So what is the potential energy formula associated with the force due to gravity? When the force due to gravity is not changing a whole lot. And we're near the surface of the planet. Think the ski slope problem. We have a limited number of potential energy formulas. Surely somebody's gonna come up on it.
Is it the one with